Welcome to our lectures on the fax devices. We shall continue with our UPQC. This is our third lecture on UPQC specially. We left it actually when from the previous class. So, we shall again start from UPQCQ. Actually, please recall our discussion in previous class. The 3-phase reference supply and the current in case of the UPQCQ are being sensed and the supply current is used in PWM controller for generation of the getting signal of the IGBT of the D STATCOM, that is the shunt point of this compensation. And for the compensation of the DVR, that is the series part, the reference injected voltage are computed from the difference of the load voltage and the voltage sensed as PCC. So, that will check that whether there is a sag or not, apart from actually the control of the harmonics. But UPQCQ mainly actually compensates sag. The 3-phase reference load voltages are computed from the desired and the reference amplitude of the load voltage and the transformation angle obtained from PLL over the sense DVR supply. So, this is the way it will proceed while working, and these are the 3 reference voltages are injected to the PWM voltage controller to generate signals from the IGBT for the DVR part. So, now we shall discuss about the control of UPQCP. So, it will inject the voltage in phase. So, this is the DVR voltage and this is the actually the DVR previously it is injecting 180 degree out of phase and is a 180 in phase. You can say something like a step changing transformer in this control algorithm, but there is a problem of the harmonics, but here change is quite smooth. The control algorithm of UPQC has been conceptualized for the minimum voltage injection by the DVR. So, it will inject voltage in phase. So, minimum injection is required and the rating can be lowered. It is evident from the phasor diagram that DVR injects the minimum voltage for both the condition of the voltage sag as well as swell. So, this is basically for the voltage sag. So, it will inject actually in phase, and this is for the voltage swell, this will inject 180 degree out of phase. In this mode, DVR needs totally the active power for the voltage injection for series compensation. So, what will happen? It will actually take active power from the system. In this case, the series voltage is injected in phase with the AC mains current or the PCC. Generally, actually current flows to the shunt path and it has been supplied to the supplied to this actually compensating the voltage in case of the sag operation, and reverse happened in case of the swell operation. Thus, the requiring only the active power and that has to be fed or received by the STATCOM through the DC bus. So, ultimately DC bus will ensure the supply and this DC bus is maintained mainly by the shunt path. It increases the current and thus the KVA rating of the STATCOM. However, the KVA rating of the DVR is minimal in this operating mode of UPQC as UPQCP, since it is only inject the in phase component of the voltage, but series rating increases because it has to feed the real power through it. In this case also the D STATCOM compensates the reactive power of the consumer load and all the current related to the harmonic problem. So, this just acts as a shunt active power filter, and the voltage sag can be represented by, as we have represented in case of the UPQC Q, voltage at the load minus supply voltage by voltage after compensation LC and supply voltage Vs by VL. Ultimately, this difference is supplied by dVr. So, it is dVr by voltage after compensation. Therefore, the voltage rating of the compensator may be achieved from the required maximum value of the sag and swell compensation. Thus, what will be the rating then in case of the UPQCP? UPQCP mode of operation requires minimum injections of the voltage and thus minimum VA rating for dVr, but D-STATCOM will actually pay the cost for it. But at the expense of the D-STATCOM rating, which increases due to the large flow of the active power, large active power flow through the D-STATCOM. Therefore, this type of UPQC does not have a minimum value of VA rating, and it consists of both the element of the UPQC. The rating calculations of the D-STATCOM and dVr is done below as done in case of the UPQCQ. So, it is basically dVr rating will be actually LC minus Vs, that is, you can write VLC into the fraction of the sag or swell. So, thus overall VA rating of the dVr will be given by dVr into Is, that is VLC into IL into cos phi, and where Is and IL are the supply and the load current respectively, and cos phi is the load power factor. So, it will depend on the load power factor. So, current rating of the D-STATCOM is essentially ID SAT should be IL square minus Is square plus x, that is a fraction of the sag x IL cos phi square. So, please note that there is a 2x, one x for actually impedance, another x for the, here actually x stands for the impedance, not for the voltage sag. The VA rating of the D-STATCOM is SDST equal to LC by LC into IDST. Similarly, you can find it out the rating of the total, that is SVR plus SDT. So, the total rating you will find it is not at all optimal. The real time control and implementation of this UPQC is straightforward, similar to the what we have seen in case of the UPQC Q, that is the D-STATCOM control in the case of the UPQC mode of operation. For the control of the dVr, the reference injected voltage are computed from the reference load voltages sensed at the point of common coupling. It is same here. The phase reference voltage, the 3 phase reference load voltage are computed from a desired reference amplitude of the load voltages and the transformation angle obtained from PLL over the sense PCC voltage, as there is a 3 phase reference load voltage are to be in phase with the PCC. These 3 phase references injected voltage are given to the PWM voltage controller to generate the reference voltage, and this will be injected with the series compensator. So, control of the UPQC as S, where we try to optimize essentially the rating of actually UPQC P as well as UPQC Q. In this control approach, the UPQC has been featured as most general one. So, we try to compensate, we actually our apparent power of the UPQC is fixed, that is VA rating of the system is fixed. So, full utilization of the DVR rating with the reduced burden on the DStatCom or optimum sharing of the rating between DVR and the DStatCom. So, here it is possible, thus overall actually rating of the system is minimized. So, let us understand the phasor. Here in this case DVR not necessarily will inject the voltage in phase or quadrature, it can inject any optimal angle. So, for this reason this was a voltage before compensations and DVR injects some voltage with an angle. So, this angle actually will make this voltage Vs, and thus with the new voltage this become a new angle VL prime, and it was actually the angle between the load and the voltage was VL, and this will actually will be injected by the DStatCom, that is the value of the IDST. Ultimately the current will become in phase with the voltage. Similarly, for sag compensation, this was uncompensated Vs prime, ultimately VR will inject this voltage, and ultimately for this reason actually new Vs will be this and VL was this, and definitely this is the IDST, the DStatCom current that will be making phase with this actually the compensated voltage. From this phasor diagram, the DVR may inject voltage for both condition of the voltage sag as well as voltage swell compensation. So, this one for voltage sag and this one for voltage swell. The UPQC S mode of operation of the DStatCom is normally used for current based compensation other than full reactive power of the system. In this case, DVR injects voltage in series with AC mains and the load end actually at the predetermined phase angle with the PCC. So, ultimately task of DVR and the DStatCom is been actually segregated, and ultimately they will decide the which angle and for the voltage and current to be injected and which phase. They need both active power, as we have seen that it is not injecting in quadrature, it is not neither it is injecting in phase. So, some portion of the active power also require, and the reactive power both from the DVR. This concept of the UPQC with the phase angle control of the series voltage injection, the DVR has been perceived recently for the different objectives. So, let us see the objective of the UPQC-S. The first objective of both this mode of UPQC is based on full utilization of the DVR rating. So, you can adjust in such a way the rating of the DStatCom and rating of the DVR is fully utilized. It is not underutilized in case of the UPQC P or UPQC Q. Usually voltage source converters is of same rating are used for DVR and the DStatCom to reduce the inventory. So, you have a actually same kind of thing to be purchased. So, you have a component count get reduced by manufacturer, and the customers are identical for identical voltage source converters are selected for both the component of the UPQC. In general, DVR is used with an injection transformer, but transformer is not mandatory unless customer need it, because system will be bulky. Sometimes we require the galvanic isolation that is prescribed by the grid code, or it can be a choice of the customer also, then we will provide the customer transformer in case of the D-STATCOM. The control of this mode of UPQC is as follows. The voltage injected by the DVR is rated voltage, that is DVR R, and the phase angle DVR psi, so the psi DVR at which it is to be injected with respect to the PCC voltage is DVR psi is pi minus cos inverse of V square plus DVR square minus LC by 2 Vs DVR. So, from there you get the optimal angle actually psi DVR to be injected, in which phase the DVR to be injected, where Vs is a supply voltage under sag or swell condition and LC is a load voltage after compensation. So, see, this is the rating. So, ultimately this is the injected DVR voltage. We assume that magnitude of the Vs and VL are almost same, they are lying in a same arc. So, you have injected this value of the DVR with an angle of DVR psi. So, new VL become this, and thus actual voltage Vs become equal to VL. And now what happened, you inject some value of the actually ICH. So, that this is a shunt current. So, that will make this is IA, it was IS prime component and this was IL the load current, and in load current harmonic component now it will be shifted to this point and the real power will be compensating by this ISH double prime. So, this will make this IS in phase with the Vs. So, thus let us find it out what should be the rating and control. The active power DVR rating definitely is that actually DVR I cos phi DVR. So, IS is coming from actually the source current and the cos phi component of it is the real power, and the reactive power will be given by DVR IS sin psi. This condition of DVR is considered for compensation by the DVR with minimum active power and minimum reactive power with full utilizations of its rating, where actually DVR rating has been VR and where DVR should be equal to VR. So, you will utilize the full rating of it. The VR rating of the DVR is DVR into IS. Similarly, in case of the IDST we can calculate from the phasor, that is IL sin beta square plus IL cos beta square minus cos phi by x 1 by x, where x is a voltage sag, and from there we can calculate the value of IDST, and since it is connected with the supply voltage, so it will see the shunt voltage will see the Vs. So, it will be Vs into IDST will be the rating of the D-STATCOM, and so therefore, the total rating of the D-STATCOM is actually DVR plus SDT. This condition of the UPQC actually what happened, it is reduced the burden of the individual voltage source converters. What happened in UPQC Q and P, one of this converter is burdened more. Here load has been shared by the both the converter equally. UPQCS reduces the burden on the D-STATCOM rating as same portion of the active power, some portion of the reactive power of the load is supplied by the DVR. So, let us see some reference generation technique that is required to control the UPQC. We shall discuss a very common theory of reference generation, that is called synchronous reference frame theory. So, there are large number of control algorithms that are used to control the D-STATCOM and the DVR. We have discussed it in day before yesterday class. Among this above mentioned real time control technique for the generation of the reference signals for control of voltage source converter of the UPQC 3-phase 4-wire system. So, we shall add some kind of new addition. We shall consider that it is in a distributed network. For this reason it is 3-phase 4-wire system. So, for this reason STATCOM will either have a 4 legs or midpoint of the capacitor can be connected with the neutral. The 3-phase 4-wire system covers concept of the both 3-phase 3-wire as well as the 4-wire system. So, if you do not consider the 0 current, then essentially it leads to the 3-wire system, and if you consider the 0 current to be available here, then we can treat them as a 3-phase 4-wire system. Hence, the control algorithm for the 3-phase 4-wire system is discussed here, and you just cut out the 0 current, make 0 current 0, then it has become a 3-phase 3-wire system. So, SRF theory, that is actually T transfer theory control algorithm for the operation of the DSTATCOM and DVR is discussed now. So, this is the overall block diagram of it. Please try to understand. This portion is for the DVR and this portion is for the DSTATCOM. Here in DSTATCOM portion we have a 4 leg. One leg is for compensating the 0 sequence current, and another topology is possible, but there is a problem of we require a splitting of the capacitor and also balancing the capacitor voltage. So, we will sense the 2 voltages, we did not have to sense the 3 voltages. So, we can generate another voltages for 3-phase 3-wire system. Then for the 3-phase 4-wire system we require to sense all the 3 voltages. From there we shall transfer to ABC to DQ frame by Park transformations with the help of the PLL phase lock loop, and that value will be fed, that is actually in a DQ frame there will be actually Vs and Vq, and we know that the harmonic content present can be actually 6n plus minus 1. So, ultimately when you will pass through this actually the low pass filter, then the frequencies that corresponds to 50 hertz will pass, that will looks as a DC in the DQ frame. So, ultimately you will get a VDC reference, that is for the fundamental, all the harmonics will be truncated by this actually low pass filter. And similarly with the Q we will have this value, and again we require to maintain the voltage sag, and to maintain the voltage sag what happen, you will also sense the load voltages at the point of common coupling, and we will actually see that what is the amplitude of the VL, and accordingly we will actually we will check with this actually the reference voltage sag, and from there you will feed to the PI controller. It is because it is better to convert this quantities also in DC because PLL is available. So, ultimately we shall check the value of the VQ here with the reference VQ magnitude. So, we can feed to the PI controller, and PI controller will add the sum value of VQR, that is the component required to be injected for actually compensating the voltage sag, and that will add up with the Q component of the voltage, and thus we will again transfer to a DQ 0 to ABC frame, and we shall generate actually VLA reference, VLB reference and VLC reference, and we will fit to the PWM block or the space vector modulation block. So, then this portion of the system will work. Similarly, we will actually generate PLL for current in case of the voltage, and we will generate PLL from voltage in case of the current or DVR portion. So, from VA, VB, VC we get the PLL and we get IL, IV, LC. So, ultimately you have actually ID, IQ as well as IQ 0 in case of the 0 component current. And so, 0 component current is fed through as it is and it is passed through the low pass filter, and you know that actually IDC should be 0. So, for this reason actually you fit IQ equal to 0, and here we require to maintain the DC bus voltage. For this reason it will take little bit of real power. So, LPA you sense this actually the DC bus voltage, and to wipe out the ripple you have a low pass filter and you will compare with this actually reference DC bus voltage and you feed it to the PI controller. So, some amount of the real power is required to maintain the DC bus voltage, that is the loss component of it, and that is fed to the ID and it is add up. And similarly this component I0 also will come here and you will convert to DQ to ABC, and that is basically we have shown here it is coming for as a neutral current, that is ISN, and it will be fed to this actually the PWM block A, B, C, and ISN will be corresponds to this block, the fourth leg only when the 0 sequence current is present, and this will actually compensate the DVR. This is the principal operation of the SRF mode. So, quick take on from this, the control algorithm of this 3-leg voltage source D-STATCOM of the UPQC based on the synchronous reference frame is discussed for the control of the D-STATCOM. The objective of the D-STATCOM is to enhance the power quality of the supply current as well as to support the common DC bus voltage of the D-STATCOM and DVR by absorbing the active power. The control schemes from the D-STATCOM, the load current ILA, ILB and ILC, PCC voltage VA, VS and VC, and the bus voltage VDC of the UPQC are sensed as the feedback signal. So, from there we have actually reverse Parkes transformation, the load current from the ABC frame to first converted to the DQ frame. So, this is a Parkes transformation where cos theta and sin theta is obtained from the PLL over the voltages. PLL signal is obtained from the voltages for generation of the fundamental unit of the vector for the conversion of the sense current to ABC to the DQO frame when you have a 0 sequence component of the current. The SRF control extract the DC quantities by low pass filter, and hence non DC quantities, that is the ripple, are being separated from the reference signal, as well as if it is a noise contaminated with it, that also get eliminated. So, ultimately you have a D axis and the Q axis component current consisting of the DC that will look as a fundamental component will look as a DC in DQ frame, and the ripple negative sequence as well as the harmonics, because if it is a negative sequence it will appear as a actually second order, because it is rotating at a omega speed of omega. So, negative sequence will look like a 2 omega. So, it will come as a double frequency oscillation, and same way 5th and 7th will come as a 11 and actually will come as a this kind of reference. So, SRF can be operated at the unit power factor or ZVR, that means 0 voltage regulation modes. We can compare, we have discussed both the modes. So, it can be actually use either of it. This control strategy actually considered as AC mains must deliver the active power to maintaining the DC bus voltage, meeting the losses of the UPQC. Now, output of the PI controller at the DC bus voltage of the UPQC is considered to be the current I loss to feed the losses of the different part of the component of the UPQC. Switching loss, all the losses should be fed, that component is I loss. Therefore, the amplitude of the reference should be added. So, ID star become IDC plus I loss. The reference supply current must be in phase with the voltage at the PCC with no zero sequence component. Therefore, to obtain the zero sequence component, we do the reverse Parks transformations and with IQ star as 0. This resultant IDQ difference are again converted into the reference supply current using the Parks transformation. The reference supply of the neutral current ISN is set to 0 for the neutral current compensation. So, same for the DVR. What we do for DVR? The control block of the DVR of the UPQC, in which the synchronous reference frame theory is used for the reference signal of the generation, consisting of the voltage at the common point of common coupling PCC, the supply current, load terminal voltage VL are sensed, and for the drive actually getting the gate signals. PCC voltage are converted into the rotating reference plane ABC to DQ, and by the Park transformation. Similarly, you have a DC component and the load component for the SD and the SQ frame, and from there AC amplitude of the amplitude of the AC load terminal voltage VL is controlled, and we compute is actually the VL star. Output of the PI controller is considered as a voltage VQ to be injected by the DVR to compensate the voltage sag. So, amplitude of the AC voltage terminal VL is calculated from the load terminal, that is given by this equation. Then PI controller is used to regulate the reference voltage value. So, the SRF will have a quadrature, and this component, this is a quadrature component and this is a direct axis component. The reference load voltage in ABC frame is obtained by the reverse Parks transformation with VLD star, VQ star, and this actually the zero sequence component is set to 0. The reference load voltage VLA, VLB and VLC and the sense load voltage VLA, VLB are used in a PWM control to generate the pulses, both the converter of the DVR as well as DSTATCOM. So, similarly, we shall have the PI controller, we should make these regulations, and the output of the PI controller, considering that we have a QR to be injected by a DVR, and we can calculate what should be the amount of the QR present. And thus we conclude our discussions on UPQC. So, we have checked the rating of all the component, and we have discussed how it can be designed by SRF technique. We have a different kind of control technique, same principle and theory will be followed, and students are actually consider that reference generation technique, different reference generation technique, and compare them with any other control technique. Thank you for your attention. In next class, we shall continue with our UPFC operation.